So we're back and we're going to look at dissolution again. And we're talking about magnesium stearate, where we had done the demonstration with vitamin C in water. So we're going to make a little further step. We're going to take something. Remember when you were in 3rd grade and the teacher made a volcano and put baking soda?
Yes, I actually did this.
Sodium bicarbonate, and you put your thumb in the big wad, and then you took vinegar.
Yeah.
It's just vinegar from the kitchen. So we're going to pour some vinegar into the beaker.
I think I got an A on that science project.
That was a good one. So we have here plain old baking soda. We actually put this into capsules. Then we have baking soda, and we mix this with a normal amount of magnesium stearate that would be used in the manufacture of a dietary supplement or a drug, and we mixed it for 20 minutes in a blender. So they're identical, except this has magnesium stearate added. Now, let's see. Let's test that this really is vinegar. Would you drink some of this?
No. No.
But it's vinegar. Yeah. So anyone can do this at home. This is your basic baking soda, and you would expect that you're going to have a reaction. So it's the same as that volcano in 3rd grade. This is an exothermic reaction. So it's a chemical reaction. The bicarbonate has reacted with the acid, so it's a base acid reaction. Now, this is the one that we mixed with some magnesium stearate.
The same stuff that they coated that vitamin C with.
The same kind of flowing agent that they use to make the vitamin C. And people say, well, it really doesn't do anything. Some manufacturers say that it doesn't cause a problem. It's used everywhere. Well, it shouldn't be used everywhere, in my opinion.
Okay.
So we're going to take it, we're going to add it to the vinegar, and lo and behold, what we've done is stop the laws of physics.
Oh, exactly. That's not
this should have a nice violent reaction, but it does show that this stuff does coat. And this was mixed for 20 minutes, which a lot of people will mix things. They put all the ingredients in 20, 30, 40 minutes is what's prescribed for in that mix. And so it just goes in, and they mix it, it coats the particles. And where you see this is what we were talking about with the disintegration and dissolution of tablets. When you get these tablets, many times that are made with these flowing agents that coat the particles, sometimes they go through your system into the toilet, and sometimes they break apart, and 10% is absorbed or available for absorption because it dissolves, maybe 20, 30, 70%, but it can vary batch to batch, manufacturer to manufacturer.
Yeah.
So it's interesting.
This is absolutely amazing to think that this is sitting in vinegar.
Yes.
I don't know if the camera is getting this, but it is absolutely. It's still dry. I can't get it right.
So, and that was 20 minutes with a prescribed amount of magnesium stearate right out of the pharmaceutical books.
This guy's still bubbling.
It's still bubbling. If we stirred that, it would all bubble. It's kind of in its little clump back at the bottom there, and there we go, and it's gone. So.
Well, that is very dramatic proof that an eye can see that maybe some of the things that are in vitamins shouldn't be there.
It's in pharmaceutical products, it's in dietary supplements, and it's in OTCs. And I think today, it's been around since 30s, 40s, or something like that. They used to actually try and make time-release tablets with it in the pharmaceutical industry back in the 50s. And you would just add more magnesium stearate to slow its dissolution in the apparatus that you're testing it with. And whether it did it really in the stomach or it just passed through, we don't know. That's many years ago, but older pharmaceutical manufacturers will tell you that was the agent of choice for a time release.
Well, if you say that they're in various forms in different products, wouldn't that mean that we're sort of adding it up? We're getting not just in some vitamins, but you might get them in some drugs. You might get some in some.
You have to understand, the point of this is that it's not really a detrimental substance as far as it's part of meat when you eat it. It's part of those fatty acids.
So it
doesn't hurt you. Okay. But whether or not you're able to get past the barrier it creates to have the product dissolve and be absorbed, that's the whole question. That's the thrust of what we're doing here is looking at that, and you'll see later that it can inhibit dissolution and therefore may very easily act as a barrier to your absorption of the product when you need to get that dosage in your body. So Tye,
Yeah.
I'd love to make you present this, but I'm not going to.
That's yours.
This is pharmaceutical technology. It is April 1985. And this is when I first saw proof of what I thought magnesium stearate would do. And I started making products with no Mg Stearate in 1984. This is drug excipient interactions from powder mixing, and it is a complete study on mixing a product, an ingredient with magnesium stearate, and the dissolution profile that you get. And we can actually put this on the screen. There's a dissolution profile you get, time versus how much you put into the product of magnesium stearate. And this is 1985, and you would think, well, this is pretty cutting edge at that time. But let's go just a little further back. This is a doctoral thesis from the University of Nottingham. This is the original, 1973.
Okay.
And in here, this entire thing is on magnesium stearate and its properties of coating particles, and the time, the longer you mix it, they show electron microscopy of how to fill in the little cavities of a particle, so you have a sharp edge, which we'll get a little bit in the first part of the mixing, and it goes into the little valleys. So these are...
Is that what it looks like snow or something?
Yes,
over the
yes.
top of a
And
mountain?
here you just have a few particles that adhere, and the longer you mix it, the more the particles adhere, and it actually fills in. It's like moon craters, and you'll see that it fills
That's what it
in.
looks like. It looks like the pictures of Mars or something.
And this entire book has photos of this, as well as the evidence of the shear action of machinery. It's got, here's the old machines. This is 1973. This is the old machine that they used to do this.
It's amazing that somebody was interested in this all the way back then.
The man who wrote this for his doctoral thesis works for me. I was doing a talk like this in front of 40 people, and he just walked in one day, he'd been here for about 6 months, and he dropped it on my desk while I was doing the talk and said, "You might want to look at this." And so I opened it up and I went, "Oh my gosh." And it was everything I'd been talking to people about from pharmaceutical technology, and some of what they're basing their knowledge on, I'm sure, came from this doctoral thesis. And he has 75 references as to magnesium stearate and all the things that it does from everywhere from 1959 on. So it's quite amazing.
Well, you've got the absolute photographic proof.